We are seeing the topic that is partial differentiation, and under that we are seeing it is total differential coefficient. So we are directly dealing with the example. We'll see here we will define the definition of composite function and how to proceed for the question on total differential coefficient. Okay, so here the example is given. If u equals to f of y minus z, z minus x and x minus y. So we can say here u is a function of y minus z, z minus x and x minus y, and it is asked to you prove that what is it, del u by del x plus del u by del y plus del u by del z equals to it is 0. This we have to prove, that is addition of these three equals to 0. Now here directly u is not expressed in terms of x, y, z. It is given to us that u is a function of these three quantities. Okay, so we cannot directly calculate that this del u by del x, del u by del y and del u by del z. ये हम डायरेक्टली नहीं निकाल सकते बिकॉज एक्सप्रेस नहीं किया हुआ है डायरेक्टली. ठीक है, तो हम इसके लिए क्या करते हैं, इसमें आई टेक दिस क्वांटिटी एज सपोज t1. आप कोई भी वेरिएबल ले सकते हैं. आई टेक हियर t1, दिस एज t2, दिस एज t3. so that we have just noted here t1, t2 and t3. so after that we can say that u is a function of t1, t2 and t3. this we can say, and t1, t2, t3 we know that this is expressed in terms of x, y and z. so I can say that t1, t2, t3 are functions of x, y, z. so that is written here, u is a function of, it is t1, t2, t3, and t1, t2, t3 are functions of x, y and z. therefore we can say that u is a composite function of x, y, z. so this is the definition of composite function. Okay, so we'll proceed here now to solve that example. We have to find out this partial derivatives. so for that, first of all, I differentiate this t1 with respect to the x, then with respect to y, then with respect to z. These three quantities we calculate. so differentiating t1 with respect to the x, if I differentiate partially with respect to the x, other variables are treated as constant. मतलब y और z constant रहेंगे, तो derivative of y that will be 0, derivative of z will be again 0. okay, because हम x से differentiate कर रहे हैं. अगर मैंने y से differentiate किया तो derivative 1, इसका 0. then with respect to the z अगर हमने partially differentiate किया, then the derivative of this y will be 0 and of z it will be minus 1. ठीक है, वैसे फिर t2 को हम डिफरेंशिएट करेंगे x, y, z से. अगर x से किया तो -1, y से किया तो 0 बिकॉज देयर इज नो टर्म ऑफ y, और z से किया तो इट इज व्हाट 1. सेम वे t3 आई डिफरेंशिएट विद रिस्पेक्ट टू द x, इट विल बी 1. विद रिस्पेक्ट टू y डिफरेंशिएट करेंगे -1. विद रिस्पेक्ट टू z करेंगे इट विल बी 0. so which is written here, this derivatives we require later on for the example, so that's why we have already calculated. okay, now we'll apply the total differential concept and composite function definition here. now first of all we have to find out this del u by del x. ये हमको निकालना है, that is the differentiation of the u partially with respect to x. ये निकालना है. so we have already noted that u is a function of t1, t2, t3, and this t1, t2, t3 are functions of what is it, x, y and z. तो हमें निकालना है u, हमें डिफरेंशिएट करना है u को with respect to x. so we have to go through this t1, t2 and t3. okay, so अगर मुझे डिफरेंशिएट करना है u को विथ रिस्पेक्ट टू दी x, तो मैं क्या करूँगा, पहले आई डिफरेंशिएट द u विथ t1 एंड देन t1 विथ x. दिस विल बी द फर्स्ट क्वांटिटी, दैट इज del u by del t1 by del x, प्लस देन आई डिफरेंशिएट द u विथ रिस्पेक्ट टू t2 एंड t2 विथ रिस्पेक्ट टू अगेन x. so del u by del t2 by del x. then again I differentiate the u with respect to t3 and t3 with respect to again x, that is del u by del t3 and del t3 by del x. similarly we have to find out the del u by del y and del u by del z. एक सिंपल चीज़ बताता हूँ मैं आपको कि after getting the del u by del x, if I want to find out the del u by del y, I will replace just x by y. अगर मैंने यहाँ पे x by y से रिप्लेस किया, so I get the del u by del y, and to get the del u by del z, I replace just y by it is z. so this three equation we have got, del u by del x, del u by del y and del u by del z. या अदरवाइज आप इसके थ्रू भी निकाल सकते हैं. अगर मुझे u को डिफरेंशिएट करना है y से, सो हम कैसे जाएंगे, u को हम डिफरेंशिएट करेंगे t1 से, t1 को करेंगे y से, देन u को डिफरेंशिएट करेंगे t2 से, t2 को करेंगे y से. u डिफरेंशिएट विद रिस्पेक्ट टू t3 एंड t3 विद व्हाट इट इज y. and similarly to get the del u by del z, I have to differentiate the u with t1, t1 with z, u with t2, t2 with z, u with t3 and t3 with z, so that we can write down these quantities. And one more thing, if you observe here, u is a function of 3 variables, okay, and these 3 variables are again a functions of 3 variables. So therefore all our partial derivatives are involved here. अगर सिंगल वेरिएबल का फंक्शन था तो वहाँ पे हमको ऑर्डिनरी डेरिवेटिव्स लगाना पड़ता था, ओके, बट यहाँ पे ऑलरेडी 3 वेरिएबल के फंक्शंस है, इसलिए हमने सब पार्शियल डेरिवेटिव्स का अप्लाई किया हुआ है यहाँ पे. इज इट ओके? नाउ फर्दर इक्वेशन नंबर 1 में अगर आप देखेंगे तो दिस सेकेंड क्वांटिटी in each term that already we have calculated there, the differentiation, okay. Again in the second equation, the second quantity that I have circled here, that already calculated, I substitute all this value, that is derivative of t1 with x. T1 with x is 0. Then t2 with x, the differentiation, what is it? T2 with x is minus 1. Then t3 with x is plus 1. So this already we have substituted here, and just solve it, we get this del u by del x. Same, हम del t1 by del y, del t2 by del y, del t3 by del y, this we substitute here in the second equation to get what? Del u by del y. Already निकाला हुआ है, and then similarly del u by del z can be obtained. अब तीनों क्वांटिटी मिलने के बाद I have to just add, because I have to show that addition is equals to 0. So हमने addition किया LHS part का, then RHS part को हमने as it is लिखा, and we are seeing that this del u by del t2 is having opposite sign with this del u by del t2, which is cancelled. वैसे फिर del u by del t3 is cancelled with this del u by del t3 with opposite sign, and this term also get cancelled of t1. So this way we got this quantity as what it is, 0. So we have proved this way, that is by using the concept of total differential coefficient we have proved the quantity as it is 0 to you, okay. So आपको हमेशा क्या करना है, it will be not directly express that particular variable in terms of some function. So उस समय आपको t1 t2 t3 लेना है, या अदरवाइज t1 t2 लेके उसको then solve करना है, okay, and then find out the corresponding differentiation and apply the rule of total differential coefficient, okay. So this is the way of solving the example on total differential coefficient. Thank you.